Hi, good day, and welcome to my third video on remainder and factor theorem. Today, my main goal is to explain what purpose getting the quadratic on top has, and why sometimes it's important to use the long method rather than the short method. So let's cover some basics here first. First of all, let's start off with something easy. Let's start off with a quadratic equation. Over here in pink, I have a quadratic equation, and I know it's a quadratic because it has 2x squared and x and something without an x. Now, most of you should be familiar with quadratic equations, and whenever you draw a quadratic, it's either you're going to get a U-shaped graph, or if you were to draw it, you might get a kind of rainbow-shaped graph or N-shaped graph. It's one of the two shapes. And in most instances, it's going to cut the x-axis. So you see the y on the x-axis here. Most times, well, a lot of the times, I won't say most, a lot of the times, it will cut the x-axis at two places. It doesn't matter if it's U-shape or N-shape. There's a high probability that it will cut the x-axis at two places. Now, because it's x squared and the squared is obviously a 2, it will have 2 points it will be cutting the x-axis at. Now, let's just assume I haven't actually solved this quadratic, right? But my favorite method of solving the quadratic is to actually use the quadratic formula. Some people prefer factorization. I'm not a fan of factorization. I just prefer to use the quadratic formula. So, if we were to use the quadratic formula on these two, my made-up questions, my made-up quadratics, let's assume that it cuts the x-axis at -2, and it happens to cut the x-axis at 3. I would say the solutions to this quadratic is -2 and 3, because that's where it cuts the x-axis. If this one were to cut at -5 and let's say +7, I would say the solutions to this quadratic is -5 and 7. Great. And it cuts the x-axis mainly because at 2 points, mainly because of the squared here. So let's move to a quadratic now. In the quadratic, you notice the highest power is x to the power 3. So if you were to draw this quadratic, but I haven't actually plotted on a computer program or anything, I'm just telling you what we most likely would get. How a quadratic has a down or an up. A lot of quadratics have an up and a down part. Now, which means it cuts the x-axis at 1, 2, and 3 points. So let's say here was -5, here was 2 on the x-axis, and here was 7 on the x-axis. That means there are 3 solutions to this quadratic, and they are -5, 2, and 7. Even if it went the other way, say it went like this. It went down, then it went up. That means, let's assume here is -1. It cuts the x-axis at 2, and let here be, 11. So that means this quadratic has 3 solutions or 3 points where it cuts the x-axis. So I think you see what I'm getting at. The solutions to the curve, whether it's a quadratic or a quadratic, is figuring out where it cuts the x-axis. Now, here's the thing. To solve a quadratic or to figure out where it cuts the x-axis, there's an easy way. You can just use the quadratic formula, or you could factorize and put each bracket equal to 0. But for a quadratic, there isn't a formula to figure out where it cuts the x-axis. It has more of a procedure to figure out where it cuts the x-axis. So today, when I ask you to solve this quadratic, we are really trying to figure out where it cuts the x-axis if we were to draw it on graph paper. And there is no formula to use at the beginning of the question to figure out where it cuts the x-axis, unlike its counterpart, the quadratic, which has a nice formula. So let's begin. I'm going to show you how to solve this quadratic. You're probably not, this quadratic, sorry. You're probably not going to like it, because every time I tell my students on how to solve this, they groan and they mumble. All right. So here's the thing. It's a guessing game. Yes, you heard me correct. It's a guessing game. You have to guess a number for x that when you replace x, you will get exactly 0. Usually, when you're guessing, you try to choose numbers between -4 all the way to +4. Most of the times that will work. But let's say I'm one of the students in the exam and I have to guess. I'm going to guess the wrong value for x, so you get an idea of what you might encounter in the exam. Let's say I guess x to be 2. That's between -4 and 4, right? Let's just replace all the x's here with 2. So I have 6, 2 to the power 3, minus 13 to the power 2 squared, 2 squared plus 9. Replace this x with 2 also. Let me work this out on the calculator, and in the exam you'll be hoping that this works out to be 0. So 2 to the power 3 is 8, 8 by 6 is 48, 2 squared is 4, 4 by minus 13 is minus 52, 9 by 2 is 18 minus 2. Let's add this up. 48 minus 52 plus 18 minus 2. Nope, we got 12. So I have to guess another number. So you can see the frustration. I understand the frustration of students in exams. They have to guess this number. And of course, you waste a lot of time in the exam. So, well, I already worked out the question beforehand, so I already know the answer. And I know if I had guessed +1, it would have boiled down to 0. So my first guess is not going to be 2. Well, my second guess technically is 1. If I go and replace all the x's with 1 here, 6, 1 to the power 3, minus 13, 1 squared, plus 9, 1 minus 2. Anything, 1 to the power anything is 1. You get 6 here, 13, 9, and minus 2. When you add this up, right, I'll just double check it to make sure. 6 minus 13 plus 9 minus 2, you get exactly 0. So now I can actually start my question, because my first guess was +1. Now, in the previous videos, you would have to divide this by something. I am trying to help you figure out what that something is now. If x reduces the whole thing to 0, that means x is one of the solutions. In other words, you have to guess the first solution. So what do we divide it by? A lot of people would say we have to divide it by x plus 1 because our first guess is 1. But in reality, what you have to do, if your first guess is 1 and it's right and it makes the whole thing 0, you have to divide by the opposite of that number. So if it's +1, you have to divide by x minus 1. If our first guess was -2 and it had reduced it to 0, I'm not saying it reduces this one to 0, but if it had reduced it to 0, you would have to divide this whole expression by x plus 2. The opposite of the number goes next to the x. So, because this, and I can prove it now, because if you put back x minus 1 equal to 0 and you solve for x, you will get back 1. So that means x minus 1 is supposed to be a factor. And what do we know about factors? I told you from my previous video that if you take this expression and divide it by a factor, the remainder is supposed to be equal to 0. So Let's see if we're correct. Right? Let's start dividing. I'm going to do this kind of quick because you all should be very, very familiar with this. So x into 6x cubed is 6x squared. I'm going to take the 6x squared and multiply both of them. So I'm going to get back 6x cubed minus 6x squared. Well, you know the procedure here. You have to put a minus sign. The minus sign belongs to both items. I'm supposed to get 0 here. I did get 0. Minus 13. Minus 13 minus minus 6. Two negatives give you a positive. Minus 13 plus 6 is minus 7x squared. Right? The positive 9x joins the party. It drops down here. And we repeat the procedure. Minus 7x squared divided by x is minus 7x. Take this answer and multiply by both of them. You will get minus 7x squared. Minus 7x by minus 1 is positive 7x. Right? What are we supposed to do? Minus them. Well, minus 7x squared minus, you're going to get a 0 here. 9x minus positive 7x. A negative and a positive is a negative. So you end up with 9x minus 7x, which is 2x. Let me drop down the minus 2. He joins the party. 2x divided by x is how much? Just 2. So 2 by x is 2x. 2 by the minus 1 is minus 2. Put your minus sign. 2x minus 2x is 0. Minus 2 minus minus. Two negatives make a positive. So minus 2 plus 2 is 0. So yes, the remainder is 0, which means this is indeed a factor. But a quadratic has 3 solutions. Remember, it cuts the x-axis at 3 places. So, we figured out the first one, right? We know it cuts the x-axis at positive 1, but this was our guess. It cuts the x-axis at 2 other places. To figure out where else it cuts the x-axis, you see this quadratic on top? When you solve a quadratic, you usually get 2 answers. So we guess the first answer, and then the quadratic we get on top, we solve it using any method you wish, but I would use the quadratic formula. So in the quadratic formula, the number touching x squared is a, the number touching x is b, and the number touching x is, well, without the x, sorry, is c. And you just have to throw it into this formula. I'm not going to review how to use the formula, right? By now you should know how to use the formula. And when you throw it into this formula, you will actually get 2 more answers, right? Now the 2 other answers, now I worked it out beforehand. The 2 other answers would be a positive 1/2 and positive 2/3. Which means that if I were to draw this on graph paper, there's a good chance it will cut the x-axis at 1. It will also cut the x-axis at 1/2. And 2/3, well, 2/3 is a, I drew this kind of bad here. Let me try this back here. Draw it a little bigger. Let 1/2 be here. A 2/3 on the x-axis be here. And 1 on the x-axis be here. So 1, 2/3, sorry, 1, 2/3 and 1/2. So there's a good chance that when you draw this quadratic, it will actually look like this. Or it could look like this, the other way around. It could actually go the other way. But the point is, no matter which orientation it has, whether it's the purple one or the blue one, I hope we can see the difference between the 2 colors, it will be cutting the x-axis at these 3 points. And unfortunately for you, you have to guess the first solution. And then when you guess the first solution, you put the opposite of that next to x, and this becomes a factor. And then you divide the quadratic by the factor to get the quadratic, then solve the quadratic to get the other two solutions. So you notice that if you had used the shortcut method, you would have only gotten the remainder. You would have not gotten the quadratic to solve. So I hope you understand the purpose of the long method, and you understand the difference between a factor and a solution. And then also when you solve a quadratic and get your three solutions, you understand what the three solutions mean. The three solutions is just where it cuts the x-axis if you were to draw it on graph paper. All right, so thank you for watching this video, and of course, as usual, don't forget to subscribe. And of course, if you're interested in more videos, you can also visit my website. This is the website here. When you go to the website, you can either click on the free maths videos or free add maths videos. You'll see it on the menu bar. When you click on it, scroll down, you will see all the videos laid out neatly. When you choose your video and click on it, it will send you back to YouTube to see the video. All right, so thank you, take care, and stay tuned for my next video.